So we can start chapter 3. So we are given a function which is g of x, which is 4 divided by x minus 7. And in this problem, we are only asked to find the domain of this function. What do you think? What is the domain? What type of function is it? Do we see a radical? So when I read this function, do I say radical square root of something? It's a rational function because I read 4 over x minus 7. So it's a rational function. Very good. Good. So what can go wrong here? What can go wrong? Yes, that will be a big problem. As we know from solving rational equations, x minus 7 cannot be 0, which means x cannot be 7. Awesome. But now we're asked to take that into account and come up with a domain. How do we write it? Very good. Awesome. Union. Perfect. This is the correct way of writing it. Thank you. Awesome. 83. If you have questions, stop me. We are given f of x, which is x squared plus x plus 1, and g of x, which is x squared minus 1. We're asked to find f plus g of x. We're asked to find fg of x and f over g of x, and the common domain. And the domain of each. So, how do we start? We start by writing the definition of f plus g of x. We have to write that. We have to get used to writing that first. So what do I have? What is the answer here? What is the starting point? Yes, but let's write for everyone to see f of x plus g of x. Perfect. And now we replace f of x by, very good, and then plus x squared minus 1. There is no need of parentheses when we add. So we combine like terms, these two go away, and we have 2x squared plus x. And this is a new function that was created by adding the original functions. Just a lot of writing. There is really nothing. Definitely nothing smart. Okay, fg. Let's write the definition, what this means first. Perfect, awesome. F of x multiplied by g of x, and then I write them as x squared plus x plus 1 multiplied by x squared minus 1. I have to perform the operations I see. I have to eliminate parentheses. So what would you write?
I'm so interested.
Say it again.
I'm so confused.
Yes, it's a lot of writing in these, but it is nothing sophisticated, I would say. Would you agree? Just a lot of writing. So we have to distribute. X to the fourth, very good. Plus x cubed. We start from the smallest one. It doesn't matter. You don't have to change your style. But I prefer multiplying from the smallest one. This has 2 terms. This one has 3. So x to the fourth plus x cubed plus x squared. And then minus x squared minus x minus 1. Combine like terms. I only have these 2 that go away. I agree. So then the simplified form is x to the fourth plus x cubed minus x minus 1. Okay. I should have asked you from the very beginning, what is the domain of f? Of course. It's a polynomial function. Awesome. Very good. What is the domain of G? Of course. Perfect. It's all your number. It's a polynomial function. So then what is the common domain then? Of course. That's common to both. This will always be the domain of the sum, the domain of the difference, and the domain of the product. Always. Once I identify the common domain, I don't have to write it again as being the domain of the sum, domain of the difference, and domain of the product. I don't. It's very clear. Notice that one function is missing here. Which function I did not say anything about? Right. Because it may or may not be the common domain. So now we are down to the last item, which is the ratio. So let's take a look. Any questions? Stop me, please. The requirement was the sum, so you can do the difference if you want. There's no problem. If you want me to do it, we can. We just have to distribute -1 to x squared minus 1. This and this. So now we determine the domain of these two. We want to create this function and find its domain. Is that okay? Okay. This part is a review from a previous course. All this part is not, should not be new, but I did it from scratch. I wanted you to see it again. So this is by definition f of x over g of x. Agreed with this? So then we copy x squared plus x plus 1 over x squared minus 1.
Gotta slow down.
It's just copying polynomials. Okay, Chris is back. Susie is not. Leon is here. Joseph is here. Is here, yes. Joseph is here. Moses is here. Abby is here. Harris is here. Ryan is here. Reggie is back. Luke is not. Stephen is here. And Kyle is here. Good. I only needed to return one test, and now I remember everyone's name. Good. So, if what? If what? Excellent. How many solutions does this have? Correct. X plus 1, x minus 1. So then what are the two options? Very good. So now what is the domain of the ratio, which is not the common domain? Yes? Perfect. Union. Say it again. Oh, we have infinitely many real numbers between -1 and 1. Yes. -1 to 1. Union. Very good. This is indeed the domain of the ratio. Awesome. Well done.
Wait, so for the x squared minus 1, so you just pull the denominator out? That's all.
If you remember from rational equations, we have to state that the domain is not, the denominator is not 0.
Okay.
So I factored it to find the x values, because that's why I asked you, how many solutions am I looking for? So I factored, and I solved, and I got 2 solutions. So these are the 2 numbers that have to be excluded from the common domain. Oh, she's here. Well done. I have to change this. I thought you abandoned us. You wouldn't do that to me. Okay. Is this clear now? Very good. Here's the next question. I'm sorry?
What's the last one?
This? Plain English. Everything except these 2. That's what it says. Everything except these 2. From -infinity to -1, union from -1 to 1, union from 1 to infinity. They're all parentheses. They exclude these two. If I made a mistake to put a bracket, then I included it. Is that better? Yes? Okay. We want to decompose. This is 89. And we have h of x, which is x squared plus 2x minus 1 raised to the 4th power. Joseph, is this okay? No. The other Joseph. Yes? Is this okay? Is this clear?
Yeah.
Okay, perfect. So here we want to decompose. Let's decompose. We're asked to create an inner and an outer. There is more than one correct answer. But what would be an example of the inner function? What do you think?
X squared, x squared, x squared.
Awesome. That's the first function I have to apply to x. And then I get a number. What is the next function I apply to this number? Awesome. Very good. Well done. 93. F of x equals 4x minus 4. I changed this function a little bit. So it's not exactly 93. So we're asked two things. We're asked to find the inverse, and we're asked to graph both. F and F inverse. Okay. I have to ask myself the first question, is this function one-to-one? Because if it's not one-to-one, you will not have an inverse function. Is it one-to-one? Say it again?
Yeah.
Why? To each y, there is only one x. Is it one-to-one?
Yeah.
Why?
Same number.
It's correct.
Yeah.
Why is this function one-to-one?
One in
Because it's linear, and we know that linear functions are one-to-one. That's a very good explanation. Perfect. So then we have a 4-step procedure for F inverse. Very good. So it is one-to-one because it's linear. And we looked at the graph last time. And by the horizontal line test, it's linear. Good. It's one-to-one. So number one, first step for the 4-step procedure.
Replace f of x with y.
Very good. We write y equals 4x minus 4. Very good. Because f of x and y mean the same thing. Good. Next question. Next step, I should say. Yes. What allows us to do that? We want to replace y by x, and we replace x by y. We've never done this before. Is it allowed? And if it is allowed, why? Because the y value for function f becomes the x value for which function? For f inverse. Awesome. That's why we are allowed to do it. Good. Step 3. What do we do in step 3? Yes. So I was solving for y by adding 4 and divided by 4. So y equals x plus 4 divided by 4. Final step. In final step, I replace the notation y exactly by inverse. Yes, you're right, but f inverse. So it's x plus 4 over 4. Perfect. One more time, you already told me what type of function this is. Let's repeat one more time. Linear, very good. How many points I need to graph a linear function? And the most important ones are the x and y intercepts. So when x is 0, how much is y? And what is the ordered pair that we just determined? Awesome. Now I make and now I make y equals 0. I have to move 4. So 4 equals 4x. How much is x? 1. Is that clear? Yes? We divide both sides by 4. 4 times 1 is 4. Okay, everyone? Very good. So what is the ordered pair that we just determined? 1, 0 indeed. So let's graph. I have two ordered pairs to plot. One is 1, 0, and the other one is 0, -4. I graphed f of x equals 4x minus 4. The problem is asking us to graph both on the same coordinate system. Without any calculations, can anyone give us two ordered pairs that will help us graph the inverse function?
X and Y-intercept.
Yes,
Oh, so
with no calculations because it's possible.
4, oh, negative
0,
0, -4, and then,
So -4, 0, right? So if the function takes 0 to -4, the inverse function will take -4 to
0.
correct. So this point is going to be here. And the other one? Very good, 0, 1. Now, before I draw this graph, if you remember something very important, the graphs of f and f inverse will always be symmetric with respect to the y equals x. Yes. So please graph y equals x first. This is not part of the graph, but where f crosses this line, f inverse must cross, because this all points on this line are 1, 1, 1, 2, 2, 2, 3, 3, 4, 4, 5, 5. Reverse 4, 4, 4, 4. Reverse 1, 1, 1, 1. So the points on this line, if a point is part of the function, it will also be part of the inverse. Mandatory. So this is f inverse, which is x plus 4 divided by 4. So please keep this in mind. Last two problems as I read. Yes? So as you see, if my graph is perfect, I know it's not going to be, but if my graph is perfect, you can see that this overlaps this, and this overlaps this. It's not a perfect graph, but it's not bad. Yes, Joseph, go ahead. Yes.
Step 3. Say y is equal to step 4.
I add 4 and divide by 4. Say it again. Is that okay? I'm solving for y by adding 4 to both sides and dividing by 4. Is that okay?
how'd you get the second blue point?
This one?
No, go the graph. On the blue line. Not the dotted one.
This one?
Yeah, I know
Okay.
you got
So-
-4, 0.
-4, 0, 0, 1.
Okay.
I reverse this, and I have to reverse this. I have to reverse both points, right? So if the function takes 1 to 0, the inverse function has to take 0 to 1. So if 1, 0 is a point on the function, 0, 1 will be a point on the inverse function.
Oh, I see.
They
the
have
one.
to be symmetric.
Never. I see. The bigger blue dot is the one I thought I was supposed to be looking
Oh,
at.
okay.
But it's not.
So these are symmetric. They're not perfectly symmetric, as you see. I have a little bit longer here than here.
That's just to show the point where they meet. I guess.
Yes, yes, they have to. So if, and you will see, we're going to look at chapter 4. When we get to chapter 4, we get something like this. This is a very, very important function. Very important function. Here it is. You will see what it is. Is it 1 to 1? Of course, by the horizontal line test is 1 to 1. So this is what line? Y equals x. So the inverse function will not cross that line. So this is the function, this is the inverse. But here, our function crosses y equals x. So imagine that this is a point like 1, 1. Now you reverse 1, 1, still get 1, 1. So it means that the function, the inverse function has to cross, has to share that point. Because you can reverse 1, 1 and get a different point, right? So you still get 1, 1. Does it make sense? Okay, good. Other questions here? Other questions here? Are we okay? So the last question deals with section 2.8. So we have two ordered pairs, and this is problem 105. 2, 6, and negative 12, 4. And here we are asked to do two things. We're asked to find the distance. We're asked to find the midpoint. I recommend let's start with the midpoint because it's the easiest thing to do. Midpoint means we're adding the x values. Please add the two x values.
Wait, come on.
Add the x values, the x coordinates. What do we get? Negative 10 divided by 2. Let's add the y values. Divided by 2. That's it. So the coordinates of the midpoint are, always remember that, the average of x's, comma, the average of y's. By the average we mean we add them up and divide by 2 because they're 2. Okay, we are also asked to find the distance. So always write the formula. I recommend that. And it's x2 minus x1 squared plus y2 minus y1 squared. And remember that the quantity under the square root must be positive at all times. I label them as x1, y1, and x2, y2. And I carefully write underneath. So this is my x2, I write negative 12. This is my x1, I write 2. This is my y2, I write 4. This is my y1, and I write 6. And now I try to perform the calculations. Negative 12 minus 2 is negative 14. Negative 14 squared. And I better get a positive number, so just square 14. Plus 4 minus 6. Bless you.
Excuse me, thank you.
4 minus 6. Negative 2 squared. 4. Very good. So this is the square root of 200. And remember, we have to simplify it as 100 times 2. So it's 10, the square root of 2. So that's how we get the exact distance between these two ordered pairs. The length of the line segment connecting them. Any questions? Again, this was a review from a previous course. So the last one, which is not review, is x squared plus y squared minus 4x plus 2y minus 4 equals 0.
This is number 111.
111, yes. So here we're asked to identify whether this is a circle or say it's not a circle, whatever. So I remember the equation of the circle, which is x minus h everything squared plus y minus k everything squared equals r squared. If I manage to present this in this form, which means a completed square with x, a completed square with y, plus, and a number that is positive, then I will conclude, yes, this is the equation of a circle. If I cannot do this, or this number is negative 5, who knows what else, then I'll say, no, I'm sorry, it's not the equation of a circle.
That's R.
R squared, the radius squared, yes, lowercase r. Okay, so obviously it's clear that I have to complete two squares, one with x and one with y. So let's say this with this, what do they need as the third term? From the completing the square method. Yes, please, Joseph.
I'm sorry, is that pi squared?
R.
H, R?
This is lowercase h, this is lowercase k, and this is r, lowercase r. H and K are the center, since you are not here, H and K are the center, the coordinates of the center, and R is the radius of the circle. It's always a good idea to, when you get the chance, to look at the previous lecture whenever you miss class. Okay, so then what does it need? What is the third? Yes, perfect. Because we have -4 divided by 2, and we get -2, and we square -2, and this is exactly what we have to add to both sides. So this and this and this are here right now. Something squared will give us x squared minus 4x plus 4.
Wait, what? Oh, I'm sorry. How do you get the +4?
The completing the square methods requires you to divide the middle coefficient by 2, square the answer, and that's what you add to both sides. So -4 divided by 2 is -2, and -2 squared is 4. And we have to add 4 to both sides. So then, a binomial squared is x squared minus 4x plus 4. Which binomial squared? Indeed, x minus 2. Remember, that's why this is what we did on the first day of classes. That's what we did, the first handout, because I wanted you to understand how important this is. Okay, and then plus. So now we are trying to complete the square for y squared. What do we add to both sides? Indeed, very good. 1. So the middle coefficient is 2. We divide 2 by 2. We get 1. We square 1, and this is what we get. So now this and this and this are in here. What binomial squared is y squared plus 2y plus 1? Very good. Awesome. Excellent. So now what is left? There are 3 numbers left. This, and this. These have not been used yet. But obviously, what do I have to do to -4 first? Move it to the other side. Perfect. Add 4 to both sides. So I have a 4 from here, a 4, and a 1. What does that mean? Very good. Is this the equation of a circle? Of course, because I have a positive number, I have a completed square with y, and I have a completed square with x.
How did you just cross? What? How did you cross the 4 and the 1 out from the left side?
1, 2, 3 are in here. 1, 2, 3 are in here.
Okay, I see.
Because it's a binomial square, which is a trinomial.
I'm sure.
And that's okay. And then we have -4 going to the other side, 4 plus 4 plus 1. So what is the radius?
3.
Good. What is the center? Careful.
2.
Exactly. Very good. 2, -1. And if we're asked to graph this, let's do it. We start with the center. (2, -1). And we go 3 up, 3 to the left, 3 to the right, and 3 down to create 4 points. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Why 3? Because the radius is 3. 1, 2, 3. So this is the graph. Very good. Any questions? Yes?
The way it includes what here in the video complete. I know it's x squared plus minus 4x minus 4, correct? For 4 sides.
A binomial squared will never have the third term negative. It's not possible. A binomial squared always has the last term positive, no matter what. So a plus b squared or a minus b squared will always have the last term positive b squared. You said something like x squared minus 4x minus 4. Is that what you meant? Maybe. That's nothing.
Because I'm looking at x squared minus 4x. Are we not using the minus 4 on this side?
You cannot. That's why we determine this number. You cannot use this number. When you square x minus 2 squared, The first document we filled out. The first document we filled out on the first day of classes. That's why, because this is very important. The first term squared minus 2 times the first times the second plus the second term squared. So that's why we need the positive 4 and we cannot use the negative 4. Does it make sense? So when you expand this, you have x squared minus 4x plus 4. When you expand this, you have y squared plus 2y plus 1.
So, but why are we having plus 4 on the other side?
Can you add 4 to one side of the equation without adding to the other?
So minus 4 is the only thing left.
No. The question is different, I think. Joseph, can you add 4 to one side of an equation without adding it to the other?
In this case, no.
No. So that's why I have to add 4 to both sides. That's why I have to add 1 to both sides. I can't change the balance. I ruin the balance of the equation if I only add to one side. Is that better? And then I have the negative 4 to the other side. This is the only class you missed the entire semester. And we have to spend some time on it. If you have some time after class, we can sit down and work on completing the square.
So
Yes?
my first one is why did we add, oh, okay, so we added plus 1 on both sides, correct?
Yes. Yeah. Is that better?
Yeah.
Perfect. So we have, we start now chapter 3. So what we covered from chapter 2, including the horizontal stretching and shrinking, will be on test 2 and chapter 3. And when we finish chapter 3, we'll schedule test 2. Is that okay? Okay. So you can say again, are we talking about polynomials again? Yes, we will. But we are not going to talk about one that we completely exhausted.
That's the easy one.
That's the easiest one. We're going to look at quadratic. And you can say, but you already taught us how to graph a quadratic function from transformations. True. But now we are going to go into more depth. And we're going to look at third degree polynomial function, fifth degree, and any odd degree. Notice that I'm not talking about symmetry here. I'm talking about polynomial functions that have degree 3, 5, 7, and so on and so forth. It has nothing to do with symmetry. And we will also look at fourth degree, which behaves identically with the sixth degree, and so on and so forth, any even degree. So later on, I will repeat this several times, and I will remind you that the linear and any odd degree will have something very important in common, as well as a quadratic and any even degree, they have something in common. And I will refresh your memory when I say that and why, and I'll explain why. So for now, let's talk about the quadratic. This is section 3.1, quadratic. And then as we progress in this chapter, we are going to look at the third degree, fourth degree, fifth degree, sixth degree. Okay, so we have two possibilities for the quadratic. The quadratic function can be given to us in two different ways. Here's one way, ax squared plus bx plus c. We've seen this over and over in previous courses, and we've seen it here with the quadratic formula. Here's another way. Let's say a x minus h squared plus k. I caution you that h and k here, although we just looked at the equation of a circle, have nothing to do with the circle. Okay? This is another point which we will identify in a minute. We will know what it is in a blink. So let me give you an example. Well, let's say we have f of x, which is negative x plus 2 squared and plus 4. I already know everything about this from chapter 2. What is the base function? One more time, what is the base function? X squared. Where does it go first? To your, very good, to your left 2. And then, no, in order of operations, please. No, reflection. I have to multiply by -1 first and then add 4. In order of operations, one more time. So x squared, then left 2, then reflect, and then what is the vertex? One more time. X squared, 2 to your left, reflect, up 4. What is the vertex? All right, -2, come up 4. This is the vertex formula. Look at it. Compare these two, exactly how we did to the equation of the circle. So it's -2, and this is whatever it is. We didn't even graph it. I only look silly with my arms up and down, right? But we know how to graph this in a blink. Why? Because we studied transformations. So by simply looking at the graph, we know where it's going and what is its vertex. But let's start first with this first form, and then we'll go and work on a problem with the second form. Okay, so let's look at an example. You can choose if you want. We're on page 360 if you wish. If not, I will. I will choose 32, unless you want to choose. 32 on page 360. And that is f of x equals 5 minus 4x minus x squared. The question is graph, and we have several steps to go through. What type of function is it?
Quadratic.
Perfect. If you said polynomial, I would have had to say yes, and then I would have asked you what type, and you would have said quadratic. It's a big umbrella of functions called polynomial functions, and this is quadratic. Perfect. What do you think I am going to do first?
Put it in order.
Exactly. Put it in descending order. Thank you. By the way, I asked the question. I'm sure you already know what the answer has to be. Perfect. It has to be in descending order. First step, I need to find the shape. As we know, quadratic functions either look like this or look like this. Both graphs are called parabola. So when you're asked what is the graph of a linear function, you will say a straight line. If you're asked what is the graph of a quadratic function, you will say a parabola. Obviously, this has a vertex, and this one has a vertex. This one is a minimum, and this one is a very good. Perfect. So how do I know? I already know the shape, right? I already graphed it. No, this is a different one. Sorry. I was still thinking of the previous one. We're not there. We're done with that one. Okay, so how do I know which shape it is? For the same reason, yes. It's the same reason, because the leading coefficient is negative. So it has a maximum when the leading coefficient is negative. Let's put less than 0. It has a minimum when the leading coefficient is positive. Because the leading coefficient is -1, which is less than 0, the parabola will have a maximum. As you know from the previous course or courses, the leading coefficient is negative, parabola has a maximum. The leading coefficient is positive, the parabola has a minimum, which we know. We know from here. Look, this is the A. It's negative, and we already graphed it. It has a maximum. So even before we graph it, we can identify whether it's this shape or that shape. So it's a maximum. The vertex is a maximum. Good. And the parabola opens, we say, downward. Step number 2. And step number 2 is the vertex. The vertex is this point. And we need to identify or determine, if you want, the coordinates of the point. So, how do I determine the x-coordinate? Let me trigger your memory. I know you know this from your previous course, but let's look again at the quadratic formula. Can anyone give us the quadratic formula?
Negative b plus or minus square root.
That's all I needed.
Oh.
This is the x-coordinate of the vertex. So if you remember the quadratic formula, I think you should always remember, be able to recall the x-coordinate of the vertex. So let's determine it now. Negative b over 2a. Negative. How much is b? Perfect. Awesome. How much is 2 times a? Very good. I see 3 negatives. What is the answer? Perfect. So the x-coordinate is negative 2. Is
Oh.
that okay? 2 times a is negative 1. 2 times a is negative 2.
No, I get that.
So what was the question then?
There was 2 problems of the 2 functions we were given. Weren't we given 2 functions? Am I crazy?
So the problem 32, so this was something else, was a different example.
Right, but right there on the number 32, I don't know why I'm lost. It says f of x. Oh, we put them in order.
But I cannot I cannot identify a.
No, it's my fault.
Is that clear?
No, yeah.
So we cannot identify a, b, or c if we don't arrange the polynomial or the quadratic function in descending order. That was the first step.
I know.
Okay, very good. No, just to remind everyone. It's okay. Good. So now how do I determine the y-coordinate? So we have a function, we determine an x value, and we want to determine the corresponding y. How do I determine that? Of course. So this will be nothing else but f of negative 2. Of course. Thank you. So let's find f of negative 2 as being negative 2 squared minus 4, negative 2 plus 5. Careful how you plug it in. You're replacing x by negative 2. So how much is negative 2 squared? With minus in front. Perfect. And how much is negative 4 times negative 2? Very good. And plus 5. So 5 minus 4 is 1. 1 added to 8 is 9. So that's the vertex. Any questions? Okay, let's look at the x-intercepts now. And something very important, comma. Yes? Minus 2 comma 9. Yes. So let's talk about this first before we continue. Okay. So does this function have a max or a min? Very good. So here are all possibilities for a maximum. There is nothing else but these 3. Here's one. Here's the other. And here's the third one. How many x-intercepts will I find here? Distinct x-intercepts. How many will I find here? Yes, it's 2 solutions, still 2 because it's quadratic, but they are the same. So we say 1 solution. But we know we mean 2, but they are the same because it's quadratic. How many x-intercepts will I find here? No x-intercepts. So now from the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. This quantity, we have not talked about it before because I waited till today to talk about it, because this is when it's important. This piece, just this piece, not the square root, b squared minus 4ac is called the discriminant. The discriminant. Now, what type of this number will the discriminant be here when we find two distinct solutions? Distinct meaning not the same. So remember, numbers can be, real numbers can be positive, 0, or negative.
Positive.
Exactly. So this quantity must be positive because we get two distinct solutions. So b squared minus 4ac must be positive. What is the option here in which we find two solutions but they are both the same? What could this quantity be, or what should it be?
0.
Exactly, because there is only one solution. So then b squared minus 4ac must be 0 here. And finally, what is the option for b squared minus 4ac here? Negative, because I can't take the square root and get a real number. So then in this case, this is less than 0. So every time I get to step 3, the x-intercepts, and I'm asking myself, do they exist? Because I don't want to waste my time. So imagine that the vertex is negative 2, 9. The function has a maximum. And I want to identify if it's this case. In other words, I should find the x-intercept. If it's this case, which will be the vertex itself, or if it's this case in which there are no x-intercepts. Remember, the vertex is negative 2, 9. Is it this case, or this case? Number 1, number 2, or number 3? Right. Why is it the first one? Because it's a positive value. The maximum value is positive. Here the maximum value is 0. Here the maximum value is what type of number? Negative. So obviously I should be looking for the x-intercept. It's this case. The maximum is not 0. The maximum is 9, somewhere above the x-axis, and the maximum is not a negative number. So it must be this situation. I will not be wasting my time looking for the x-intercepts. So let's do that. So how do I find the x-intercepts? But yes, that's true. But what do I have to write? I have to write something in order to find the x-intercepts. How do I find the x-intercepts for any function? I said, that's what, it's true. I said y equal to 0. The x-axis is altitude 0, right? Y equals 0. So then we have, what was it? Negative x squared minus 4x plus 5 equals 0. Perfect. We know we will find two real solutions because the vertex is a maximum, and the maximum value is a positive number. Perfect. So now you already know what I am going to do to this equation first, which is? No, because it's quadratic. I want 0 on one side, but something is in the way which I refuse.
The negative.
Exactly. Never accept or agree to solve a quadratic equation with a negative leading coefficient. So then x squared plus 4x minus 5 equals 0. We have 4 methods. Will I complete the square? No. Will I take square roots? I can't. What are the options then? Or quadratic formula, or yes, if it takes a blink, I'll factor. If it takes more, quadratic formula. Can I factor this in a blink? Yes, I can. So what is it? Good. So there are two options, x equals 1 and x equals negative 5. I would like to write the ordered pairs. Now, if we make the mistake and write 1 comma negative 5, that's a terrible mistake. So what are the x-intercepts that we just determined?
0, -5.
Perfect. What do you think number 4 is? Of course. Thank you. How do I determine the y-intercept? And there is no if it exists. It will always exist. How do I determine the y-intercept for any function? Very good. So I have to find f of 0. So how much is f of 0? Yes. The function, the original function, is this, 0, 0, 5.
So it's 5.
5. So the ordered pair is?
0, 5.
Awesome. Now 5, 6, and 7 are just words. Very important though. You'll see when we get to solving word problems in a minute. 5, I didn't mention, now this is the time. The parabola is a symmetric graph. I'm not talking about odd or even. I'm talking about it's symmetric with respect to its axis of symmetry. The axis of symmetry is the vertical line passing through the vertex. So what I'm saying is that this side is symmetric of this side with respect to its axis of symmetry. So let me remind you, in our case, we have a -2, 9 as the vertex. So imagine is here, -2, 9. What is the axis of symmetry? It must be a line that is vertical, passing through -2, 9. What vertical line passes through -2, 9? Of course, x equals -2. It's the x coordinate of the vertex. Awesome, thank you. So now what is the maximum value since this function has a maximum? Maximum value is, awesome, the y coordinate, perfect. So finally, I would like you to determine the range. And you can say, wait a minute, you haven't even graphed it. Yes, we already have it in our head. We already see the graph. What is its range? Exactly. See, now we really know every minute detail about this function. We really do. Okay, so now let's graph it. When we graph, we always start with the vertex. Can anyone give us the vertex one more time? Very good. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. I have to draw the axis of symmetry, which is not part of the graph, but I have to graph it. It will help us keep the graph in shape. It has no other use. So x equals -2. I continue with the x-intercepts, 1, 0, 2, 3, 4, 5, -5, 0. I continue with the y-intercept. And now when I graph this function, I try to make it not as acute at the vertex. My graph is, as you see, far from being perfect. I'm having some difficulties graphing it smoothly. No one expects you to graph a perfect graph. So this is the graph of f of x, which is -x squared minus 4x plus 5. Now, if you remember from the previous chapter, what if I ask you, is this function ever increasing?
Yes.
You will say yes. For which x values?
-infinity to 9.
To -2, indeed. For which x values? From -8 to -2. Is this function ever decreasing? From, for x values between -2 and infinity. Very good.
Is that going to be a question?
Say it again.
Is that really going to be a question?
Yes, we've done this. You had it on the previous test. I will always connect the concept so you don't forget.
Oh, my land.
And